So thank you everybody for joining. Good morning, good afternoon, good evening, where are you? Um, Today we're going to talk about model context protocol. And as usual in my sessions, I take a theme and run number of sessions, which basically try to bring a holistic perspective to the topic. Agents are becoming really very mainstream. So this series is more focused on the agentic AI. The approach will cover some concepts, talk about technologies, and have demos. So I'll have 15 minutes each uh, for these things. I will take questions in the end so that I can finish my agenda. I'm purposely keeping the session at a conceptual level because that is what I've seen most of the time if you attend any technical seminar session. Either they're selling their product, services, or they are too superficial or too deep. Um, and I thought I can bring in some value to the community by having a balance of uh, both concepts and the implementation. And I'm just trying to make it simple so that anybody who's interested in Gen AI can take benefit out of it. These are not training sessions. You can't really learn something in 45 minutes, but I can assure you each session will give you a very solid foundation about a perspective of the topic or the theme that we're going to talk about. I use Azure. That's the primary platform, but whatever I'm discussing is not specific to Azure. This is a platform model agnostic, open source approach that I've chosen. So the frameworks, language, and tools that I'm going to discuss can be used anywhere um, you want based on your technology platform. This is a continuation of the series. I had number of sessions running since December 2003. I've got the recording which I've shared in the invite. In case you are new or miss, you can always go through this recording at your convenience. So let's start and let's focus on something which is uh, the main topic of any discussion that we have in our consulting um, work. How AI has evolved, that is very well articulated by Jensen Huang in his keynote speech. Uh, and, in fact, I saw a news item where NVIDIA has become a 5 trillion company. This is the biggest company. So he has been the main beneficiary, but that's not the point. So if we look at the journey or the evolution path of AI, it started with the perception AI. It's been there for last 20, 25 years. I've been working in that space, uh, speech recognition, text to speech, speech to text, image classification, object detection. These were the things which were there for long. But in last 3, 4 years, um, Gen AI caught the fancy. It has become mainstream thanks to ChatGPT, which was launched sometime in this November 2022. I'm correct, and that gave uh, a new dimension to AI. It's a generative AI, basically does generation, like perception, which is basically trying to figure out what is there. There are numerous use cases: content creation, summarization. Um, all that is very familiar to most of you. The focus of this series is on agentic AI, and we will see it from a different perspective. And going forward, you would see the physical AI manifesting in the form of uh, a Tesla car, which is fully um, autonomous driven. You have humanoids But if you see, the evolution has been incremental and cumulative. So whatever we did in that perception AI era is useful in the generative, and generative AI forms the basis of agentic AI, and physical AI is going to embed all that which has been innovated and invented in this um, life cycle. So this is a good perspective, and I recommend you to watch that YouTube video. Um, Now, since the theme is agentic AI, let's understand very simply what is an agent. Uh, Gen AI models are good. You have Chat GPT, you ask question, ask a follow-up questions, and you can do as much only. The agents takes that discourse to the next level, where you can actually assign a task or prescribe a goal to the agent to do things of its own. So the most important capability the agents have is the capability to reason. Obviously, agents need an AI model as the brain, but agents takes uh, this to the next level by making use of tools, resources, and prompts or instructions. So the way agent works, uh, it has an underlying model. It has access to tools and resources for grounding and context, and you can provide them instruction through prompts for it to really carry out, you know, that goal. There can be uh, configuration in terms of an agency where you have multiple agents, but all of them kind of follow this concept. Now, why am I discussing it here? Because when we have an agentic application or an agentic architecture, we need to integrate based on the framework that you choose. Could be semantic kernel, autogen, LangChain. Uh, you need to have integration with tools, data sources, which provides the context, and also you like to have some standardized templates for instructions, and that is what MCP is addressing. So model context protocol is an open protocol that standardizes how applications provide context to LLM, or essentially how uh, basically agentic architecture will get what it needs to carry out its task. It's like a USB-C port. Prior to USB-C, we had different types of power adapter, different connectors for different types of devices that you have. And USB-C kind of brought the standard in terms of connecting your screen, your monitor, your external storage drive, and that made things very easy from a manufacturing perspective. In the injecting world, the same concept is utilized. You basically use MCP as the protocol to connect to tools, data, and all other things that is required as part of your application architecture. And we'll see that through examples. Why we need this? The agentic AI demands things to be done differently. They need to connect to various systems, data sources, and if you start doing the integration or plumbing yourself, you would have a lot of challenges, and then probably what you build will not be extensible. So what basically MCP does, it provides you an integration layer which is agnostic of your underlying LLM and the provider. It's a standard open way to integrate all those things that we discussed, and we'll see that. So let's look at the architecture. What is there in MCP? Is it a new technology? Is it something um, which is you know uh, different from what we have been doing in the past. So fundamentally, this is kind of very standard client server architecture. So you have an MCP host here, which is like a system which will run an MCP client. So if you develop web applications, so you have an application as a host, and then you create, if you're making a call to an API endpoint, you make an HTTP endpoint, a client that would invoke that endpoint URL. Very similar. On the server side, again, you have a host which basically provides the integration layer, which is compliant to MCP standard. Behind the scene, it may access local storage, it may access cloud object storage, can access a SQL Server database, and this MCP server can be implemented as a serverless Lambda as your function, can be a web application written in Python, can be a C# application, and we'll see how um, this works. And the underlying protocol at an application layer is called server sent event. Basically, it's a bi-directional. So you have MCP host, can be any client application. I'll show you Cloud Desktop, Visual Studio Code, or it could be a custom application. Uh, then you basically create an object or an MCP client, which basically connects to an MCP server. Behind MCP server, these are the data and function capabilities a server would provide. And there can be as many servers. They can be hosted anywhere as long as you have the details or the interface specs. You should be able to. Now, how it will work and why this is really very useful. So if you go back to the working of an agent, now the purpose the agentic architecture service basically allowing it to reason based on the context, create a sort of a plan or an orchestration, execute it leveraging tools and the context, also observe the results and take a corrective action or a subsequent step based on the outcome. Now, all that orchestration is created by the agent by leveraging language model. Unlike the traditional programming where we have a premeditated flow that has to be coded in a language, and also if once you are doing it, you can have as many paths only. Whereas in case of an agent, this orchestration is done on the fly. That means for every request, a separate plan or a workflow orchestration will be created based on the context. It will analyze what tools to basically make use of, carry out the step in a specific order. Could be a sequential orchestration, could be a parallel or a handoff orchestration, depending on whether you have a single agent or multiple agent um, configuration. But essentially, the main difference what you get in agentic AI is the ability to on the fly uh, kind of program or create the orchestration logic, run it, and get the result finally back to the. So in that case, what is important that you want your architecture to be extensible. Let's say you have currently 3 tools and you're going to add as you go and build your application or you evolve your application. In a traditional language, if you're using an API-based orchestration, um, so you would got to know every endpoint, and that's it. If anything changes on the server side, new tools or new context or the data sources is added, your application won't know it because it is basically designed with what is called an interface specification in form of Open API 3 or Swagger, and it can just do that. And obviously, you need to create your own orchestration logic, which will definitely will have finite combination only. So how MCP works? If you look at uh, the sequence diagram, a user asks something to the MCP client. The MCP client is to basically leverage LLM to figure out what tools and data is required to be fetched. And in fact, it will also query when at the time of launch, what tools and capabilities exist in the individual MCP server which are configured. I'll actually show you that. And this LLM is then deciding what tools or data has to be chosen based on the query or the prompt. You may have a human in the loop for approval that you want to do this task if it is sensitive or critical or high risk operation. You would like to keep human in the loop, and then this client or the agent is going to call the appropriate MCP server and a particular tool, which basically is going to call a backend server, or it may have a logic embedded, but that's not the point. And it'll get the response back. It'll be sent back to the LLM. LLM will generate the response, and the final response will be sent back to the user. Now, this could be iterative. That means it can be a multi-task step task, but that's basically the essence of how things are happening behind the scene from an integration perspective. Now, this is really very useful, and we'll see that. Now, let's go back, understand what are the MCP constructs. So, we have discussed about resources. Now, GenAI requires a context for doing anything, and that comes from either enterprise data or data from the web, or you provide the data as a context when you are asking a question. So that's basically the resources. MCP has um, support for that. Prompts are basically the instructions to the agent and in turn to the underlying model. So you would have set of prompts useful for the use cases that you're serving, and you really want to create some sort of a library which is fine tuned for a particular task. Okay, so that's where you can create what is called a prompt template or prompt templates, and then use that as one of uh, the capability in MCP. Tools are essential in order to carry out some action, because each agent is all about doing something, carrying out some task, writing to the database, querying from, let's say, a CRM system. And there are other things which are sampling, and unlike a normal API, which is client driven, here MCP server can also, ask for LLM completion, get some information about security and privacy. And then there are other things like routes. Routes are basically the boundaries where the server can operate. For example, you have a local file system and you really want MCP server to be limited to a particular um, uh, path, and that can be done, and then transport. Good feature of MCP is that although you see server sent event, you see MCP as a protocol, it is leveraging what is already a proven technology, uh, which is HTTP, JSON as a wire format. It is basically riding on the top of it. So really, the core infrastructure and all the integration that are there are available for you to implement MCP. So let's do a comparison, and I'm just trying to tell you here is this technology is not very different than what has been there since I think 2000, when API became mainstream as a way of integrating applications. So if you look at this diagram, and I have a purpose to show it to you. So basically, an API is nothing but uh, a functionality a server can provide. Could be a data as a function, or data as a service, or a function as a service, which are basically exposed by the backend or backend APIs. So what you have is a front end API, and it can actually expose an HTTP endpoint for various clients. Behind the scene, it is not necessary that you use HTTPS. Could be a local call to the database uh, through SQLnet or an Oracle Net kind of a protocol. Um, but essentially, from a client perspective, uh, HTTP or API is an HTTPS based interface that any client can make use. And what you have in the client, what is called an HTTP object that you create to connect to the API endpoint, make a request, get a response back. And you can have as many clients in terms of, could be a mobile application, cloud desktop. So that has been the architecture. Uh, and let's see how different is MCP. Now, not much difference. If you see, the backend technology can stay as is. What has been introduced, considering the requirement for agentic architecture, you have a protocol which is a layer 7 application level protocol. You have an MCP server, an MCP client. You create the same way an MCP client object to connect to an MCP server, provide all the information, credentials, and everything, and that's it. Now, why I'm showing it to you, this comparison, just to make it very clear that MCP is nothing very different than what we have seen, and it also uh, makes it simple for anybody who has an API-based ecosystem to enable agentic architecture. So what you have to do, you have to just create an MCP layer, and I'll show you through the code and demo how easily it can be done, and that's it. Now, once you have this MCP server implemented, any MCP client can make use of it. In fact, it is so simple. If you go to Azure API management service, if you have API endpoints, you can actually, by clicking and doing some configuration, convert those APIs as an MCP server. So if you have hundreds of API, you can categorize them and create MCP server without having to code. What is different in case of an MCP server, or the functionality that MCP server provides? It is not just about the endpoint, it is also the description that you have to give, which an agent can understand, so that it can actually make use of that tool, and then execute uh, these functionality in a specific order, and I'll show you that. So that's basically is the talk. Let me just show it to you. So the reason I have got IDE and Claude and everything, just to give you a good demo. So Cloud Desktop is a thick client application available for all operating systems, Windows, Apple, Mac, and everything. And what is, it's just like a chat GPT done differently. And what you have, this is sort of an agentic host with capabilities to connect to um, LLMs simply. So you have options to connect, do a simple call. But like I said, it has agentic capabilities also, which means you can use that as an MCP client by doing some configurations. And the configuration is very simple, straightforward, uh, like this. So there is a desktop, plot desktop.config file, and what you are basically doing, and I'm just showing you 4 different MCP server of different types so that I can explain that. So these are the 4 tools or MCP server. You can actually see them here. So I've got 5, in fact. One is a custom one. So once you configure it, you basically provide uh, the configuration of MCP servers. You will see in this toolbox all those servers listed here. You can actually click and figure out what are the capabilities or what are the endpoints or what are the functions they provide. So here, this is a file system MCP server, which is just few lines of configuration. So if you see here, there's nothing. You are basically using Node and it is using server file system MCP, and that's it. And you are providing paths to some file where you can perform something. That's basically what was the boundary I talked about, and that's it. The other one being SQLite, and we'll see. So you know that agents takes the discourse to next level. For example, you have a database like this, a SQLite database, which has set of tables. Let me just bring it up quickly. So what you have to do in order to make use of um, any SQL database. So what you need is the knowledge about the programming, which is, or the language called SQL, for you to really get information about the data that you have. For example, it has number of tables. If you want to know about a table, you got to know SQL, which is fine for people like us, but to the end user, it's not really very simple. And especially when it involves complex joining multiple tables, it is very difficult for the end user. But that's where the agents really take this course to you know uh, to the next level. For example, um, the user doesn't know, and I want to find out uh, what are the number of uh, albums are there. So let's see what is happening, and then we'll actually show you that is also give you a view about agentic. So it is actually going to write an SQL. So this is a natural language to SQL use case. It has figured out how uh, what query has to be written. Okay, it is saying this is no such table as album. It could be albums, but doesn't matter. Uh, so what it did, it has basically read the schema of the database, identified what all tables, and then reasoned over it and found out that albums are kind of similar, and then basically created a query, executed the query, and you get the same results that otherwise would require you to write, I don't know how many records are there. Hopefully there are 347. Okay. Now this is fine. If it is a complex query, I mean, one can write the SQL by learning, but what about something which is like, say, how many albums and what are the number of tracks per album, all that. Now this is the agentic part. I have to show it to you, although the working and how you write an agent is going to be the last session. But what it has done basically here, uh, created an SQL query and leverage that MCP server that we saw, and carried out this task. That's how you know uh, the agentic architecture can really be made simple from an integration perspective. So please do remember, MCP is an integration technology that is required for agentic uh, architecture. Although you can use that, but there is the value is not that great because if you are using it as a simple API, then I mean you got to know everything. You have to orchestrate everything. Okay, now let's go to another demo where um, I will show you how you can write an MCP server. So I've created a custom MCP server in Python, which is basically the architecture that I was showing. So I've got two backend system, weather API and um, aviation stack. So these are the two um, backend which provides information about weather and rights respectively. And I have exposed them as an MCP. So this is an MCP server. The car created travel MCP server. It has two tools. It has some prompt also in case and resources. Uh, and that's it. So if you have a Python application or any application, you can just convert into an MCP server very simply. And if you go here, let me just clean this. You can actually see in the tool a custom MCP server, and you can actually figure out it is providing you these options, and you can actually um, ask um, how's um, whether, let me just copy paste so that. So see how it is going to work. Agent has access to all the tool. It will say I will use the custom travel MCP server that I have created. It has identified the the schema. It knows that it requires city as an input, and it is asking me. I can actually choose to allow always, but this is the human in the loop. Before making a call, it is going to really ask for the permission from the user and to get this response. Okay, so that's basically about how do you create an MCP server. Um, these MCP client capabilities are available in most the modern IDE like Visual Studio Code. You can actually go and see um, what MCP servers you have. So you would have seen Airbnb, file system, memory, travel MCP. All these are also inside, available inside. But the purpose is essentially to enrich the capabilities of ID like Visual Studio Code, have agentic aspect, and then make use of MCP uh, technology. Now, that's really good. So what we have seen, some MCP client and hosts uh, as MCP um, consumers. We've seen the code, which basically is the MCP server that I've shown you here. Now, let's see if I have a requirement of creating a custom client. You probably have an application which you want to enhance by adding agentic capabilities. And when you add agentic capability, it makes sense to leverage MCP if you really want to build as a comprehensive solution. So what I tried just to show, this is an open standards protocol. So I've got a C# MCP client. Okay, it is making use of the travel server, which is running in Python. Okay, uh, and what it does basically creates a, an MCP client objects, have some options, and will give you the result. So let me just run it and show it to you. So what we have seen earlier was the weather information. So I've got this console application, um, which will run an MCP client, connect to the travel MCP server. Let's see if it runs. Okay, so I've got these two options. I mean, this is just for the demo. So last time we talked about weather information. So I had another endpoint uh, from the flight track, and let's see if I try to ask again. This is not agentic; it is just demonstrating the capability of an MCP client connecting to the MCP server, and behind that MCP server, you have that aviation stack. I'm just giving source city and destination city. Boom, you get the results. Uh, it has queried that endpoint going all the way through MCP client and server, and what you see is the results. It is such a profound uh, integration technology, especially when it involves agent in from in an application architecture perspective. So let's go back. So we have seen Cloud Desktop, we've seen Visual Studio Code. I've shown you a Python MCP server. I've shown you a C# client, and let's see why we should use. And I've kind of alluded already. So the benefits of MCP. So you have end-to-end and end-to-end connections, which can be streamlined by having an MCP layer. You can have multiple MCP client connecting to uh, through the MCP and enable the agentic behavior. And finally, let's summarize what we have seen. So we're talking about agentic world, which is Gen AI. To it basically goes beyond a simple conversation with the model. You basically define an agent which can autonomously pursue a complex goal and carry out some workflow with and without human intervention, depending on the critical uh, nature of your use case. And that is really enhanced by having an integration technologies like models context protocol, which is an open standard like web or API, very similar to USB-C. And that's pretty much